Hi there. This mix is going to serve as an introduction to exponential functions, just a few of the main components to get you an overview and get you started. The first thing you want to understand is the form of the function, and it looks like this: y equals a times b to the power of x. You're familiar with linear equations, and often they're in the form y equals mx plus b, slope-intercept form, and you know what the components m and b stand for. So in this form, for exponential functions, you'll notice that the variable is up there in the exponent position. So that's where your x will always be if it's an exponential function. Y equals is just what it's always been, y equals. That's the statement of the function. So y is the same thing as f of x. You could say f of x equals. The a stands for the starting value, also known as the y-intercept. Or, for example, if a was 5, if it said y equals 5 times something, then the y-intercept would be 0, 5. A is the starting value when x is 0. And then b is the growth factor. That's the guy that's going to determine whether this function is going up or down, increasing or decreasing, how much and how fast. So b is the factor that has the power on it, and it's the one that'll tell us whether our function's increasing or decreasing. When you start studying exponential functions, you want to make sure you really understand that b value, that growth factor. That controls a lot in exponential functions. If that b value is greater than 1, that means your function is going to be increasing. So if b is 2 or 5 or 1.9 or 700, the function is going to get bigger and bigger and bigger as x gets bigger and bigger and bigger. So as you move to the right, the graph's going to move up and up and up. The outputs will be increasing. If b is in between 0 and 1, like 1/2 or 1/3 or 0.7, anything between 0 and 1, the function will be decreasing. So as your x values get higher and higher, your outputs or your y values are going to get lower and lower and lower. So as you move to the right, the function is going to be coming down lower and lower and lower. Couple things to note is that the value of a can never be 0. Think about it. No matter what b or x was, if a was 0, I'm going to multiply all this stuff by 0 and get nothing. So that won't be an exponential function. By the same token, b can't be 0 either. If b was 0, then 0 to any power is 0. And no matter what a was, I'd still have nothing. So that won't work. And the last thing to keep in mind is that b must be positive. If it is a negative number, then weird things start to happen. So let's just look. So b has to be positive. Let's say b was a negative number, like -2. If I raise it to the first power, I would just have -2. If I raise it to the second power, that means square it, -2 squared, that means -2 times itself, that's going to be +4. If I multiply -2 to itself 3 times, raise it to the power of 3, I'm going to get -8. And then to the fourth power would be +16. So you can see that it jumps back and forth between positives and negatives. Every time you have an even number of powers, it would turn positive. An odd number would turn negative, and it would jump back and forth and back and forth, and that won't work. So b cannot be a negative number. Always has to be positive. So here is the difference between the functions you've been studying, linear functions, and these new exponential functions. In linear functions, you already know that what makes a function linear is its constant rate of change. So you can see that to get from 5 to 8 on this function, I'd add 3. And to get from 8 to 11, I'd add 3. And from 11 to 14, we add 3, and add 3, and add 3. So this has a constant rate of change. It's always the same. That's what makes the function linear. So now, as we start talking about exponential functions, it isn't a constant rate of change that they have. You can easily see that right here on this function here, that from 3 to 6 it changes by 3, then it changes by 6 to get to 12, then it changes by 12 to get to 24, and it starts going up dramatically. So it's not a constant rate, but what is happening is it's changing by a constant factor. Factor means something that gets multiplied. What got multiplied to 3 to make 6? 2. And what do you multiply by 6 to get 12? 2. And 12 times 2 would be 24, and 24 times 2 would be 48, and so on and so on. So that is a factor of 2. That's your B value right there. The B value is the growth factor. So on this example here on the right, it might look like it's being divided, but factor means something that's getting multiplied. So can you think of what you would multiply by that might look like division? It would be a factor that's between 0 and 1. For example, 1/3. If I multiply by 1/3, 81 times 1/3 would give me 81 over 3, and 81 divided by 3 is 27. And if I multiply 27 by 1/3, 27 over 3 would give me 9. And 9 times 1/3, 9 divided by 3 would be 3, and so on and so on and so on. So sometimes if it looks like it's dividing, you have to remember that that growth factor, it's still B, it's between 0 and 1. So if B is greater than 1, this function right here is increasing. You can see that as x goes up, y is going up. And this one, where B is between 0 and 1, is decreasing. As x goes up, y is going down. We're going to take a look at both of these functions on the next couple of slides. So here is the increasing function we just looked at on the previous slide. And this is what the function would look like in its equation form. Here's the table, and here's the graph. So you can see that, let's take a look at how we get those table values. If x was 0, let's plug it in. F of x would be 3/2 times 2 to the power of 0. Remember your order of operations. You have to do powers first. 2 to the power of 0. Anything to the power of 0 is 1. So I would have 3/2 times 1. And so when x was 0, y would be 3/2. If I plug a 1 in, we just plugged in 0. If I plug 1 in for x, f of 1 would be, this was f of 0, f of 1 would be 3/2 times 2 to the power of 1. Well, 2 to the power of 1 is 2, so 3/2 times 2 would be 6/2, which would equal 3. So when x was 1, y would be 3. And you can see these values start to take shape. If I plugged in 3 for x, then I would get an output of 12, and so on and so on. We already knew this function was increasing, so now let's take a look at the graph. Do you remember what this value stood for? A. A stands for the starting value, or the y-intercept. And 3/2 is at about 1.5, so you can see that right here on the graph, right there. Then here's the other points: 1, 3, 2, 6, 3, 12, 4, 24, and pretty soon it goes off the graph. But you can see that an increasing exponential function gets dramatically higher very, very fast as you move from left to right. It gets very, very steep, very, very fast. I apologize for my crooked line. Here's the other function we were looking at, the decreasing function, the decreasing table. And here's what its equation would look like. So Do you remember the 243 is the start value on the graph, way up there on the y-axis. It's not going to show here, but it's up there somewhere. Okay, it's way, way up there. But you can see that it's heading that direction. And so let's make a little table here and see how some of these values came to be. If I plug in 0 for my x on this function, 1/3 to the power of 0 would just be 1. So I'd get a starting value of 243, which it should have been because that represents the y-intercept. The starting value, this a value, is the same thing as a y-intercept. So if I plug 0 in, I should always get that number. If I plug 1 in there, then I'd have f of 1 would be 243 times 1/3 to the power of 1. Well, 1/3 to the power of 1 is just 1/3, so 243, times 1/3 means 243 over 3, which would be divided, and that's 81. So if I plug 1 in for x, I get 81. Let's try one more. If I put 2 in, f of 2 would be 243 times 1/3 to the power of 2. Well, 1/3 to the power of 2 means 1/3 times 1/3. Okay, got to do the powers first. So that would be 1 over 9. And then 243 times 1 over 9 means 243 divided by 9, and that would be 27. So if I plug 2 in for x, I get 27. And you can see where all these values come from on the table. And then on the graph, you can see it started way up at 243. That might not fit on the graph. But here, an 81 isn't even going to fit on the graph. But 2 and 27, you can see that right about here. Right about here. And then there's 3 and 9 would be here, and 4 and 3, and so on and so on. All of these values from the table are ordered pairs, 2, 27, 3, 9, just like they always have been. And this is a function that, since b was between 0 and 1, it was, what was b? It was 1/3. And if b is between 0 and 1, the function is going to be decreasing. So as I move to the right, you can see this function is getting smaller and smaller and smaller and smaller.